Hey, oh no, this shouldn't be there. Oh no, there we go.
Hello.
Well coordinated.
Welcome to You Choose, a choose your own adventure style show where we navigate our way through the entire CNCF landscape. I'm joined today by a great person, super knowledgeable guy, Ashley Davis. He's going to be our guest a little later. And Victor's here too.
Yeah, even I'm here.
And we got this other warm body. And a lady who laughs too much.
There we go.
Yeah, we're going to find that line of laughing too much. Let's do it. Let's really lean into it. So this is episode 4, use HTTPS. And so far we're in chapter 1 right now, and we want to get our application from the developer's laptop all the way through to a development environment just in this chapter. And so for our first episode, we chose a container build strategy. And for that, we chose...
Oh, wait. Speak.
Cloud
There
Native
we go.
Build Packs.
There we go.
Oh, no. We're not that far.
No, that's
Victor.
not the one. Okay.
Victor totally
not
zoned
listening.
out.
I'm
not listening at all.
I just thought it's a cue. Kind of like, do something, Victor. What am I supposed to do? Okay, let me put the image. Okay.
I was just trying to include you in the conversation. That was my mistake. I won't let it happen again. Episode 1, we chose Cloud Native Build Packs to build an image. And episode 2, we chose Harbor to push that image to the container registry and then now last week was episode 3. And for that one, we needed to choose a technology to define and deploy our application to development environment. So exactly. In our last episode, we had 4 guests. We talked about 4 technologies. Pretend you didn't see the winner. So those 4 hopefully you weren't paying attention either, viewer. So those technologies were Kustomize, let's see, Carvel YTT, Helm, and cdkates. So let's recap what we learned in the episode. Are you here? Are you with me,
Nothing.
Victor?
I learned nothing.
Because you already know everything. There's really you're here for output, not for input. All right. So why don't you maybe, Victor, tell us about Kustomize?
Yeah. So the idea behind Kustomize is not to use templates, not to use any of the things that Instinct might tell us to use, and overlay. Meaning you define pure YAML as is, and then you can overlay one YAML with another YAML with another YAML if you want to have variations between those results, right? So Kustomize is not helping you to have fewer lines of code or YAML and all those things. It helps you just stick with YAML and overlay it when you need to overwrite something or add something and things like that.
So during Thomas's presentation, his example was having a base manifest that you want to deploy to 3 different environments. So you would use 3 different patches or overlays to modify how you want that base to be deployed in 3 different places. So
exactly.
Only the changes between environments need to be captured in that overlay.
There is kind of unwritten or maybe written, I'm not sure, standard, but you can organize it any way you would like. But the majority of cases, people put everything the application needs in a base directory, and then overlays / production, right? And then production would have only what differs in production compared to the base manifest, and the same thing for staging and so on and so forth.
What I learned about Kustomize is that you can generate a config map from a file, or you can generate secrets, or you can also apply common labels or annotations across your project with Kustomize too. That's what I learned.
Exactly.
Yeah. I have a lot to learn. Do you want to, something else I learned that I really shouldn't admit here because it's pretty remedial, but here we go, is I didn't realize patches and overlays are the same thing. I thought they were 2 different things, and then they were being used interchangeably in Thomas's presentation.
You overlay with patches.
You overlay so overlays the verb and patches the noun, but people say patch like a verb.
Yeah, would assume that I know what's the difference between verbs and nouns. I don't. So It's all the same to me.
Awesome.
Blame
awesome.
the education system, not me.
And then next we talked about Helm, which is the de facto package manager for Kubernetes. In fact, I think I've never heard Helm defined without that term de facto in there because it's ubiquitous. But with Helm, you template out your Kubernetes resources in Golang, and then you have a separate values.yaml file. Then you can also incorporate logic in your templates with the Sprig framework. But then once that's all done, you package it all up into a directory that's called a Helm chart. So the Helm chart has to have your templates and it has to have your YAML, your values file.
Your values,
and then it can
yeah.
have other things too, like dependency charts or CRDs or other stuff.
Yeah, it is essentially, and I'm simplifying it greatly, doing the same thing like how typically people would use templates to generate web pages, right? Hey, those are the variables, those are the things that I might want to change, the rest is static. Process the template and generate the final output, which in case of Helm is YAML.
Yeah, and Helm, you use Helm to package and share applications with other entities. And a lot of times
Yes.
when you're going to consume a third-party application, that's going to be a Helm-based.
So where Helm really shines is that part, right? Independently of whether you prefer to use Helm or you prefer to something else, Helm is I'm going to modify the statement from before. I will say Helm is the de facto standard for third-party applications, right? So
okay.
if you need a Postgres database running in your cluster, you're going to almost certainly apply it with Helm, right? Or any other third party. Now, a significant number of people use Helm for their own applications, which is fine, right? But that area, your own application, that's where we have competition, like Kustomize, like other tools that we talked about. When third-party applications are concerned, then Helm is probably like 99%, right? Like I know that what we do in Upbound is package the Helm charts, not always, but partly. What you guys do in VMware as well, and everybody else.
Yeah. So then that brings us to our third technology that we're going to recap, and that's Carvel YTT. Scott Rosenberg, who's here now, presented to us about that. Victor, do you want to sum up YTT? Do you want me to do it?
YTT is almost like combining Helm, and this is my uneducated interpretation. I haven't spent years like Scott with it, but it's almost like combining Helm with Kustomize. And one significant difference, at least from my perspective, compared to Helm, is that Helm is a free text templating, right? You can just write anything or convert anything to anything else. YTT is more focused on data, right? It understands what Helm is. What YAML is,
Okay.
not Helm. It understands what YAML is, and it essentially allows you to combine. I mean, it is templating engine, but I would probably describe it rather as YAML with data than templates.
So you can have the templating of Helm and then the patching and overlay of Kustomize all in one tool. That tool stays in YAML. It understands YAML structures, so you don't have to worry about like indenting or escaping or any of that. And then it has Starlark, so where you can add programming logic to your, which is like part of what templating is, yes, but to your YAML. And Starlark is a Pythonic dialect. And then Scott showed us also using that logic to enforce like schema validation. And Scott also talked about showing an application how many lines of YAML it takes to represent that application with a Helm chart versus how many fewer lines of YAML. I think it's something like around 8,000 with a Helm chart and around 4,500 or something with YTT. I feel like there's something else. Just YAML validation in general. Like it's YAML in, YAML out, YAML all the way through with YTT, which YTT stands for YAML templating tool.
I don't know, like Carvel tools are a mystery what they stand for.
That's not a mystery. I just said it, Victor.
Yeah, it was until now. Now it's not. Now it's not.
Scott, if there's anything we missed, I know you're here, so you can let us know. But that's the gist of YTT. And part of what makes it, in our situation, in our contrived situation where we have to choose only one tool, it's a good choice because you get the benefits of a couple of the other tools all wrapped up into one.
Exactly.
And then, the other thing Scott wants to say is YTT is not specific for Kubernetes. So you can use it for Kubernetes, but any YAML, anytime you need YAML, YTT is good for it. And then we talked about cdkates. So cdkate stands for Cloud Development Kit for Kubernetes. So it should have two Ks in there, right? Cdkates.
I did not know that either. Honestly, I didn't. I know it's cdkates, kind of like.
So it's a library that a developer reports into their IDE, and then they can code Kubernetes configuration in a programming language that they're comfortable with. And it supports TypeScript, JavaScript, Java, Golang. I'm forgetting one, Python. And then, so from a developer's standpoint, it's easier to use, but then some of the Kubernetes abstractions are simplified beyond what you normally see in Kubernetes. So for example, like a lot of times if you want to associate a pod with a deployment, what the actual labels and selectors are to make that association don't matter. So cdkates might auto-generate that for you and factor it out so you never even have to see that part of the abstraction. So developers can use languages they're comfortable with and all the programming logic that comes with that. They have simplified Kubernetes abstractions to work with. And then there's a synth command that turns all the cdkates code into Kubernetes YAML. So it ends up being plain vanilla Kubernetes YAML that you can apply to any cluster. And then from the ops side, you could refactor the libraries to incorporate some best practices. You can also enforce policies that are a part of that synth command. I think that's it.
Yeah.
What did I miss? How'd I do?
No, you did great.
Thanks.
Right
I always
code.
look for your validation after. In
comes code, out comes YAML. That's it.
Yes. And the developer experience for that one seems pretty nice. Yeah. And so now that we've summed them all up, actually, before we jump to wait, I see your hand. Don't press it yet. Show me your hand. Before we sum it up, let's what's a use case for when let's talk about why you would want to use why would you want to use what's a use case for YTT? What's a use case for cdkates?
I mean, it depends. I can tell you what my personal kind of 2 cents is, right? And everybody is going to be different, right? I personally use Helm for third parties without doubt. That's always. I prefer Kustomize for my own applications because they do not require. So here's the thing, right? When you create some definitions that will be used by many, meaning you're a software vendor, and then thousands or tens of thousands or hundreds of thousands of companies might use it, you have inherent complexity there because you need to think about all the variations what everybody might or might not need, right? When you work with your own applications, and this is personal, kind of like half of the internet is going to go mad with me now, right? But when you...
Actually, this is a good opportunity to ask chat. Why don't you all weigh in? What did you vote for and why? But anyway, I also want to hear from you, Victor.
Yeah, so when it's my own applications, they don't have that much complexity, and I prefer Kustomize, right? Because the variations are mostly between different environments. Hey, production is going to have more replicas than staging. Easy stuff, right? And then when I need to create complex things, like I work with Crossplane, compositions can be, people are going complicated. Then I prefer YTT or cdkates. But that's for complex situations which are very specific. My 2 cents. Now start throwing stones.
So YTTs for when you have really complicated stuff and you don't want to use Helm for that. But then I feel like YTT is more geared toward like an operator experience, and cdkates is more geared toward a developer experience. So it maybe just depends on who's writing the
Operators who don't know how to develop shouldn't exist.
Right on.
There you go. Now throw more. No, I'm kidding. It really depends. I mean, we can now debate whether it's better to do it in this format or that format, but every single operator writes shell scripts or Python or something like that, right? So
yeah,
the language itself shouldn't be an issue. Now, whether that's a better thing to do or worse, but knowledge shouldn't be an issue there.
right on. All right. With that, who was our winner, Victor?
Now you do want it, huh? On the screen. There we go. YTT.
Carvel YTT. Excellent. And cdkates. Oh, cdkates is kind of far back behind. I wonder why that is. I think
Yeah.
Yeah, because I think Ellie gave a great presentation.
cdkates is great. I like it. But what can I say?
Actually, what can you say? It's a lot of dead air.
Exactly.
Yeah.
Actually, I made a mistake that actually you saw. I did not want to show this, but you saw even on this picture which one I voted for.
Well, are we allowed to vote? I don't think I can vote on my own. Like if I'm the one if you're the one who hosts it, you can't vote. Anyway, it doesn't matter. There were like 120 votes anyway, so we should vote freely because it drops in a bucket. Not that your vote matters. Everybody's vote matters. Everybody matters.
Oh yeah.
Okay. Now we have the next decision to make, which is not much of a decision.
Shall we do the YTT first?
Oh yeah, gotta implement it.
It's not mandatory. It's our show. We can say no.
No, I absolutely want to see us implement YTT.
Okay.
Let's do it. This is like the victory lap.
There we go. There we go. You see my screen. Okay. So I already prepared the YTT resources. Here we go. You have things that we don't need today. That's because mostly for the episodes that follow. But what matters today is that I created for my application deployment. Now, deployment has, this typical, I'm not doing anything especially fancy or complicated with YTT. Just saying, hey, replace this with value, right? Replace that with value and so on and so forth. So it's not really templating. It's more putting values into YAML. And the same, and again, if somebody watches this, don't freak out. This is more complicated than it should because I'm including all the variations for all the possible paths for all the possible future episodes. Anyway, there is a deployment, there is a service, and there is ingress. A very, very simple application, which we're going to make more complicated later, right? Everything's simple. Some values are replaced. Now, those values are coming. Those that you saw before is coming from schema YAML. So this essentially contains YAML that contains all the values that will be replaced or not. And finally, there is another one that since this schema YAML that I showed, that's generic. That's almost equivalent to the base directory of Kustomize. That's our values YAML in Helm. Now I want to deploy it specifically to the development environment, so I have a separate file which is empty, right? So the only thing that I want to make different in development from the baseline is this. I'm going to replace image tag value with whatever is the tag that we built 2 or 3 episodes ago, right? So now this is how my values dev looks like, right? I have image tag 001, and the rest is whatever is the default in the schema YAML. Now, there are a couple of ways to deploy YTT, but we did not yet explore those couple of ways. So that's coming later in the episodes. In other words, I'm going to go simple. I'm going to transform YTT into a final YAML that I can apply to Kubernetes. So I will say, hey, file. I'm going to first include the schema with the default values. And then I'm going to include the resources with the deployments and this and that. And I'm going to overwrite data values file with that image tag that I just created, which is in values dev YAML. And then I'm going to send the output of that, whatever YTT creates, I'm going to store it in YAML dev app.yaml, right? I'm going to store the output of this command into this file, right? There we go. Now this is now my final YAML, right? This is the YAML that with all the values, everything there processed by YTT. And that means that I can do something as simple as namespace is dev. I want to apply whatever is defined in YAML dev directory. Boom. When I say boom, I mean wait. There we go. Deployment created, ingress created, service created. Now, if I output the address of my application, CNCF demo dot whatever is my domain, there we go. I just realized that I'm not sharing the screen but the terminal. So I'm going to change that. Give me a second. Okay, share screen, entire screen. There we go. There we go. And if I open my application, it might work or it might not. Who knows?
Oh, the suspense.
Okay, let me see what's happening. What did I do? What did I... namespace space dev get pods. Let me see whether it's running. It is running. Get ingresses. Ingresses are there. It should work, but it doesn't. I don't know what I did wrong. I will debug it during the session and figure out. Now imagine that you haven't seen that it doesn't open in browser. Imagine that, user imagination. And I'll check what's going on. What I wanted to say, but I cannot show, and I will show later, is that this application now is using HTTP, not HTTPS. And now we need to figure out how we can transform that application into using HTTPS. That's why we have a guest.
That's why we have a guest. So normally at this point in the show, we kind of scaffold out, like, what do we need to be looking for when we're evaluating all these different tools that do the same thing. And today we only have one guest because, again, with the word de facto, we seem to have a de facto standard in the CNCF.
No. De facto standard is when there are others and you are the de facto among others.
Oh, okay.
When you are the only one, then you're de facto and actual and any other standard you wanna call yourself. Kind of like there is no other project in CNCF. Yes, outside.
Yes, yeah. Take it or leave it standard. Use it or bust. If you want to manage your certificates manually, go for it. Good luck with that.
Exactly.
Which actually you were sharing pre-show about back in the day when you used to manage certificates manually. What was that like?
Oh, that was not necessarily the types of certificates. Now we're exploring incoming traffic certificates, right?
Uh-huh.
But in the past, when I worked in professional services, we had to connect different applications internally within each other. And that requires certificates because, it's a bank. We cannot be not secured. So we need to have certificates. Now we cannot have signed certificates. We're going to have self-signed certificates as if that really matters, as if that makes it really secure because you cannot validate whether it works. But what does matter is that you need to wait for a week. And that's especially funny when you're a consultant and then you can, okay, so I have this 5-minute job left for which I'm going to wait for a week until somebody creates self-signed certificates and emails it to somebody else who needs to confirm that that's correct or not correct without knowing what the heck is happening. So he's going to forward it to somebody else and then it will reach me. And then I will realize that it doesn't work. And I will have a strong desire to open a window and jump. That was my normal day with certificates 20-something years ago.
I totally pictured you opening a window, like a browser window or a Finder window.
Yeah, I mean, luckily for me, kind of when I had like 50 kilos when I was young, so I would probably float like a leaf, so it's okay.
Just like
now it would be poof. That's it. Now I'm not opening windows anymore.
So we need certificates. Or that's just how two entities establish trust, and that's going to be applications. It's going to be machines. It's going to be VMs. Like any two things ever, right? That talk to each other need.
So there are actually there are 3 entities required for 2 entities to establish trust.
Okay.
You have 2 entities like application A, application B, or a browser and application A, doesn't matter. And then there is a third entity that says, yeah, actually this certificate makes sense, right? Otherwise, without that entity that will confirm the identity of the certificate and it really belongs where it's supposed to belong, it's just random stuff.
And that entity is a certificate authority or a CA.
Yeah, exactly.
Yes.
Exactly.
So we need certificates and we need a trusted certificate authority to assign the certificates as trusted. Yeah.
And we need something that will make me not work to get it. Best engineers are always lazy people.
Yeah,
that's a golden rule that exactly. So if somebody's lazy, hire him or her. Because that means that person is going to try to figure out how not to do work. And that means use the tools that will automate stuff.
Excellent. And with that intro, we have Ashley Davis joining us today, who's a professional certificate nerd, a self-proclaimed.
Absolutely.
Hello,
yeah.
Ashley.
And also very lazy, I can confirm.
You see?
Great. An expert. Tell us about yourself a little bit.
So yeah, I'm Ash. Hi. I'm a Cert-manager maintainer. I've been for about 2 years. I do that as part of my role at JetStack, where I am, as you say, a professional certificate nerd. My job title isn't quite that, but that doesn't matter. Yeah, I come from sort of a PKI like certificate-y kind of background, I guess. But I'm a software engineer and interested in sort of automating this stuff, which is good because that's what Cert-manager aims to do.
And does.
and does indeed.
Okay, Victor, are you gonna do the clock today?
Yes, but one thing. Wait. I'm gonna kick you all out. Wait, give me a second. I need to do something. I just realized that I used the wrong address.
Oh, I figured out why you're.
There we go.
It is. Woo!
Wrong address.
Wait. What was wrong about the address?
There was not dev. Dev was missing. I had CNCF demo domain instead of CNCF demo dev. There we go. So I'm not lying. So all of you accusing me of inventing things, and okay, there you go. Now you can continue. Whatever you want to do.
You're gonna time. We're gonna still be very strict about your 5 minutes, Ash, because
Of course.
Yeah, because we enjoy the power. Really, that's what it comes down to.
I'm going to be very strict too. I've got a stopwatch ready to go.
You know what I like the most is that it is 4th episode, and people are already starting to say, "Oh, of course,
Of course.
of course." I need to mention it.
We've got things to be doing. Like we've got discussions to be had. Being strict, there's nothing wrong with that.
Okay, go.
Okay. Could I get my slides up? So yeah, Cert-manager. I hope a few people who are watching have heard of it before. The Cert-manager is the easiest way to automatically manage certificates in Kubernetes clusters. That's what we've said as a team, and Whitney drove it home last week when I appeared on her show, which is linked in the description of this YouTube video, so you should check that out. It was already mentioned, so I'm not going to go into massive amounts of detail, but certificates are the things that you need to do TLS or SSL, or in this case, I believe we'll be using it for HTTPS, which is surprisingly hard to say. Most things need certificates, and especially it applies to public-facing services nowadays. Like everything is encrypted, and that's a good thing. And this applies just as much in Kubernetes as it does anywhere else. As I think has been mentioned, Cert-manager is a CNCF incubating project. We got incubating about 6 months ago now, I think, which that was really cool to do. It was a fair bit of work, but it's really cool validation. And actually, another cool bit of validation is we just hit 10,000 stars on GitHub, which is massive cause for celebration and just really awesome. And another thing that was mentioned is that Cert-manager is often treated as a de facto part of a Kubernetes installation. It's kind of the de facto choice in CNCF, I suppose, because it's the only thing that does this in the CNCF, but many people treat it as a standard part of the Kubernetes install, although I should be clear that it's not standard, it is a third-party project. So Cert-manager works by adding custom resource definitions, or CRDs, that represent various certificate-related tasks that you might need to do. First of all, you need an issuer, which tells Cert-manager how to get a certificate. In this case, we're using a secret that's inside a cluster, but the most common one is Acme, which you could use to get a certificate from Let's Encrypt. That would be publicly trusted, so you could use it, and anyone who has the Let's Encrypt stuff on their machine would be able to validate it. Once you've got your issuer, you'll need a certificate which describes how to actually fill out the certificate, like the things that you need in it. So in this case, we've got one for example.com, and the certificate refers back to the issuer that you defined earlier. Some certificates support setting a duration. That won't work for Let's Encrypt, but it would for our example here because that's a CA issuer. So it's inside the cluster. Cert-manager can also issue CA certificates themselves. So you can bootstrap the whole thing. You can do your own trust entirely yourself just using Cert-manager. That works out the box. In fact, it can do private PKI just straight away as soon as you install it. That can save you money and time if you're paying for your certificates. If you're not paying for them, you've probably got a rate limit, and so you can avoid that. You can avoid a rate limit by using private PKI if you so choose, and you can issue other kinds of certificates as well. So you can use them for like mutual TLS or SPIFFE. It's all complicated stuff that like maybe you don't need, maybe you do, but it's cool to have the possibility, and Cert-manager gives you that option. I'd be remiss if I didn't talk about some of our sub-projects as well, with this low-quality logo that I made for a talk a few weeks ago. There are many other sub-projects in Cert-manager, most of them obviously relating to certificates because that's the whole point. I'd just like to highlight one, which is my personal favorite, and that's Trust Manager. Trust Manager adds a new CRD on top of what Cert-manager has, which is a bundle, and that lets you specify trust bundles which you can use for establishing trust in certificates. This fixes a bunch of problems in Kubernetes, a lot of that some people might not even realize they have. I suspect we won't be talking much about Trust Manager today, but it's worth checking out if you're watching this. Like it probably is helpful to you if you're running production Kubernetes clusters. I think that covers it all, which I'm making 4 minutes and 20 seconds or so. So I think I'm within the time limit there.
Show off. You're showing it.
Nice. We need to lower the limit because I enjoy so much shoving that timer into people's faces. That next episode, 4 minutes.
It's good to keep me focused so I don't start talking about complete nonsense.
So I think in my personal life, I'm going to start limiting conversations to 5 minutes. Sorry, Victor, what were you saying?
Yeah, I was about to ask. So I don't think we answered or either of us mentioned why certificates in the first place? Why would anybody need certificate for outside, inside, any type of traffic?
I guess the key is that it helps with encryption, and more important than that is actually that it is widely supported. So TLS is kind of the thing that everyone uses to do encryption on traffic, and certificates are what TLS uses to provide identities for either one end of the connection or both ends of the connection, optionally. So it's kind of the only choice that most projects really have, because nobody wants to be rolling their own cryptography and like implementing all this from scratch. So you kind of have to use TLS. So you kind of have to use certificates.
No, I meant more like not why TLS, but what is it? What's the benefit? Why would they have HTTPS in the first place?
Oh, well, because you don't want people to spy on you and steal your credit cards and passwords and everything. Yeah, that is the more fundamental thing, I suppose. Yeah.
Tiny detail. And I think that browsers do not even allow anymore HTTP, right? I think for public.
They give you a good warning. Like with your example earlier, I saw that wasn't secure and it has a big old not secure thing. Like my browser will warn if I try and connect to anything that isn't encrypted.
And the trust, it's worth saying, goes two ways. Like, you don't want any malicious actors to come into your cluster, but you also, the people aren't going to trust you to visit your site if you don't have your certificates in place.
Yeah, for sure.
Yeah, as a user, you don't want to go to a place that isn't secure. And then something to drive home, like we talked about TLS being for trusting, like being able to trust that whoever sent the message sent the correspondence, but also encryption. So there's two things happening there. Yeah.
And it can sometimes even go beyond like the confidentiality and the trust aspect. It's just making sure you get what you asked for as well, because it used to be the case that like because unencrypted HTTP is in the clear and anyone can see it. Actually, if you're on like a coffee shop Wi-Fi or something and you go to an HTTP website, they can just change that website and they could put ads in, or they could just mangle the data in any way they wanted. So actually, it's quite important that when you're sat on potentially an untrusted network or something and you reach out to a website and connect to it, that actually you're getting what you thought you were going to get.
And you know, in the past, at least in my case, there was always, and when I say past, I mean like 30 years ago. There was always that discussion, kind of pros and cons. How far do we want in encrypting traffic, because it was kind of painful. But today, there is no tangible reason why anybody would use any type of communication in any direction without being encrypted, right? It almost comes for free in a way. When I say free, I mean from human effort.
Even like, even if you don't care about the coffee shop injecting things into your website, and you don't care about your passwords being stolen, and you don't care about connecting to who you think you're connecting to, it's worth it even to like prevent people doing novel kinds of attacks. Like if you're sending plain HTTP, people can like arbitrarily delay your network connection so that you can't download any more data. Like it doesn't use many resources. Things are fast nowadays. Like we have the CPU power to do the encryption, and it doesn't use much anyway. So it's just worth it everywhere, like by default.
Can we talk about certificate authorities? Like I hear a ton about Let's Encrypt, and I understand that you have to solve Let's Encrypt challenges to be verified to get your certificate. How do other public CAs work and establish trust? Do they have things you have to solve too?
So the underlying thing with the solutions and everything, that's called ACME. That's a standard, and other CAs can choose to use that.
Okay.
The Cert-manager ACME issuer can talk to any of those as long as they're standards compliant. Others do it in various ways. So it's not like it's easy to imagine one where like the CA comes in and actually audits your offices and makes sure that you're legit and sees your papers of incorporation. And actually, there's certain type of certificates that require that, although they're not really worth it. If you want a spicy hot take, it's not worth it at all. But like that's another way you could do it. It's essentially there's been some check to make sure that you are legitimate, and it seems to mostly work quite well. it's also all publicly trusted certificates are also uploaded to a certificate transparency log to make it clear that what's been done and make it auditable in the future. So if someone does anything nefarious, it will show up and everyone should be able to see that.
We have a question too from chat. In a world where every system could get its own valid certificate, how can you identify phishing sites?
It's a great question. So
Yeah.
A valid certificate is just one that like follows the spec, right? Like you can easily, anyone can generate that on basically any machine that has a CPU. You could do it by hand if you wanted, if you really, really wanted to. I don't know why you would. That goes back to sort of the question of trust and like, how do I know whether to trust the certificate I was given? And the only way to do that is by knowing who you trust before you try to communicate. So you can't do this at runtime. You can't reach out to someone and then try and work it out. You need to know the CA certificate before you connect to anything. And that's actually provided through usually your operating system trust store, or it will be baked into container images in Kubernetes quite often, or if you're using Trust-manager, it will be done by Trust-manager. But yeah, the key is that you have the certificate before you actually connect to anything. So, or you have the certificate of the CA, which ultimately we call it chain back to the certificate that you're presented by the website.
Because somebody theoretically could redirect you from Google to googlex.com, and that would have a valid certificate, but nobody can give you but Google valid certificate for google.com, essentially, right?
Yeah. Mm-hmm. And if you were connecting to google.com in the first place over TLS and it was encrypted, nobody can then modify that to do the redirect. So if you're connecting over HTTP to start with, then they could do that. And that's actually a known attack that means you have to redirect to, you must only use HTTPS preferably. So it's definitely something to think about.
But when we're saying Google X is the bad site, like there's nothing stopping you. Like if you're not being wise about how you browse, like if you type in Google X has a certificate that says they are who they say they are. Yeah.
Yeah, for sure. Yeah, it could be.
Because they are who they say they are. They are Google X.
Yeah, exactly.
It's important not to derive too much more trust than is presented. Like all you're doing is like someone proved that they own that domain at some point. That's probably all that you can say.
That's all that they've proven. Yeah, exactly.
Well, there's a lovely question just come in from Bill.
Oh yeah, we are getting here delayed a couple of seconds.
Oh, yeah.
Okay, here we go.
So this is like a huge question, and generally in Linux the answer is Mozilla. Mozilla decide it, and that is kind of centralized. And most Linux distributions create their trust store packages, which define who's trusted based on what Mozilla publish. And obviously that's also used for Firefox. Ultimately, it's whoever provides the trust store on your machine, or it could be you if you handcraft that, which nobody does. Microsoft do it for Windows, obviously. Google will do it for Android, and Apple will do it for iOS. It depends on the vendor of your machine as to who provided that. But for Kubernetes and for most Linux distributions, it's going to be Mozilla ultimately that decide that. And the decisions that they make are all public, so you can review the discussions they make about whether or not to include a certificate if you want to. Like that might not be the most fun pastime, but I find it kind of fun.
Professional certificate nerd.
Exactly. Just keep on coming back to that. I'm trying to nail that home. Like that's me.
That's a great question. Thank you, Bill. I didn't know.
So you mean probably you're one of those two people in a whole world that actually writes certificates by hand, right? Out of fun.
Well, I think there's a non-trivial amount of people who set up like private PKI for home clusters and like home labs and that kind of thing. Like that is, I'm not the only person in the world that does that, but it's a fun little thing.
So Bill's asking for further clarification. So does Google send their CA certificates to Mozilla?
Yeah, so Google do also have their own program for managing this, I believe, for Chrome. I don't actually use Chrome that much, but like they will have their own system. But for Google do have a CA, and they will have sent that to Mozilla and said, hey, look, we're a CA. We promise that we're legit and that we're going to treat it with respect and like have it secure and all this stuff. And Mozilla will have evaluated that against its own guidelines, which again are publicly available, and said, yeah, okay, that's fine, and then started distributing it in their trust store. So then that will have been slowly picked up by the Linux distributions that depend on that Mozilla trust store upstream.
What's the scale of a trust store? How many publicly trusted CAs are there out there?
It's on the order of hundreds. It's not.
Hundreds, okay.
It's not like a. It's not impossible to audit it if you want to do that, and some organizations would want to do that, for sure. Like at the end of the day, anyone who can get the private key to one of those publicly trusted root certificates can issue any certificate valid for any website. So it is an incredible amount of power if you get to steal it.
It sounds like a video game. Just hit the key of the power.
Yeah, like maybe the kind of video game that a professional certificate nerd would enjoy.
Those two people I mentioned before. Yeah. Exactly.
Excellent.
No, but that's the maturity of technology that I really enjoy. When it becomes, when it goes into the background, it's simply there. Not much for you to do as a user, not much for you to do especially with Cert-manager as a provider, right? It's simply there, it works, it's in the background, makes everybody's lives better without really being even very aware of it, right?
But I feel like, though, in the open source space, at least, it becomes harder to find maintainers for projects that become in the background, because people want to work on like the latest, like sexiest thing at the bleeding edge, as they say. What's your experience with that, Ashley?
I think that probably has some truth to it. Like Linux is fairly reliable, and that's got quite a lot of people working on it. It doesn't need to be a problem, but like certainly I don't see any other way around it. Like more maintainers is always great. If anyone is interested in becoming a Cert-manager maintainer, they should reach out, and I'd happily talk about that. But at the end of the day, like the overriding goal that we have to have has to be stability and not breaking people and just making things just work. And if that's not sexy to advertise, and it should be, because that's what software should do. I think that's part of the sort of joy of open source, is that you have no external motivation except to make the best product. Like if everyone's aligned, that's the goal, and it really is. There's quite a lot to enjoy about that.
Agreed. We have a question from Andy. What other issuers can be used with Cert-manager? I know there's one for small step.
Yeah, there's tons. So there are built in. You can do sort of in-cluster issuance, which is the example I showed earlier, and there's Acme, which we've been talking about as well, which you would use for Let's Encrypt. There's also built-in support for Vault, HashiCorp Vault, and Venafi TLS Protect, which can do issuance itself, and there's a whole suite. Venafi are my employer, so I should be frank about that. But like, yeah, there's an integration for that. But then you can build your own external issuers as well, and many have. So there's cloud providers have their CA programs. AWS have private CA, for example, and we have an issuer for that. They're all listed on the Cert-manager website, which I will attempt to navigate to in a browser window so I can link it in the chat. But yeah, there's loads, and you can add your own at any point. So it's open as well to be extended.
And so these are all public issuers, yes, that are then going to probably all of those are in trust stores that we were talking about earlier.
You can have private ones as well, right? Because for air-gapped environments, what we called when I was young internet. I don't know whether that's still a term.
Yeah, so most of the ones I listed are going to be private. So
Private, okay.
Venafi can sort of act as an intermediate, and not intermediate in a certificate sense, as in like it will get your request and then go do the thing itself, as I understand it. So it can get publicly trusted certs through Acme if you want to configure it that way. But Acme is the only one that's likely to be publicly trusted out of all of the ones that I listed. Like there could be external ones that can get you publicly trusted certificates, but they're going to need some other step for validation, and in practice that might end up looking like Acme anyway. But I can't speak for all of them because there's more issues than I even know exist.
Right on.
Okay, shall we wrap it up?
I think it's time to wrap it up. Do you
Yeah.
have one final statement you'd like to say about Cert-manager before we bid you adieu?
I would say thank you for having me. Thank you to anyone that's using Cert-manager, and I hope it continues to be stable and work for everyone's use cases. Thank you for watching.
Yeah, thanks. That was a very nice ending. I think I would have been more of a flex, like you'll use Cert-manager because you have to, because we're the only choice. Take it or leave it.
No, but it isn't. I mean, I've been using it for years. It just works.
It just works.
Just works, kind of.
It just works.
That's it. And when something just works, then
Yeah.
there is no good reason not to use it, especially since it's open source. It is in CNCF and all the jazz.
It aims to be, and it is, the easiest way to manage certificates in Kubernetes. Yeah. Excellent. So normally we ask you to vote about now. and we have some comments. We have Cert-manager gets my votes. So I think we're not going to go through the rigmarole of even posting one because Cert-manager just wins.
Exactly.
Good job,
Easy.
Cert-manager. So yeah, tune in next week where we'll implement Cert-manager into our ongoing demo and hit an HTTPS endpoint instead of HTTP. And then next week we're going to talk about adding a database to our dev environment. Yeah, and different
Exactly.
strategies for that.
We will
Yeah.
have votes in that one.
Yes. There's competition there. All right. Thank you, everyone, for your time. What a gift. Have a wonderful rest of your day. Bye.
Cheers, everyone.